All right, this question looks confusing. It's not that confusing. If they'd told us that sine theta equals positive root 7 on 4, our first instinct would have been, okay, that's easy. That means we're here and opposite over hypotenuse. This is 4 and this is root 7. Let's figure out this one. Root 7, 4 squared, take root 7 squared. This one would have come out as 3. Yeah? But it could have also worked for over here, where this is 4 and this is root 7. And this would have been negative 3. But they've told us that it's negative, which means they're deliberately telling us that we want to look at these two options here. So what I did was completely irrelevant. Haha. Well, actually, I kind of cut through a bit because we're going to use Pythagoras to figure out the values of this one, and this one's going to be like the negative of that one. And like I just said, we've got 4 squared equals negative root 7 squared plus x squared. So x squared is 4 squared take negative root 7 squared. So x equals 3, yeah? So here, it's going to be positive 3. And here, it's going to be negative 3. So we need to go through, and for both of these triangles, we need to find cos theta, and then we're going to need to find tan theta. So cos theta, if we have a look at the triangle on the left, we can see that it's going to be adjacent over hypotenuse, it's negative 3 over 4. Or if we look at the triangle on the right, it would have been positive 3 over 4. And then if we have a look at tan theta this time, again we're going to do it for the left triangle and the right triangle. We've got opposite over adjacent. So for the left triangle, tan theta, our opposite is negative root 7 over adjacent, which is negative 3, which comes out as positive root 7 over 3 because the negatives cancel out. That makes sense. SATC, it was tan would be positive there. And or tan theta. Now you can probably guess it's just going to be negative in this one, and you would be right. It's positive. It's negative root 7 on positive 3. Nothing cancels out. This one, the fact that it's negative, SATC, it means that it can't. If cos is negative, it's not here and it's not here. So it makes sense that we're looking, on this side. Okay, each time radius is 4 and the adjacent is negative 1. So radius for adjacent is negative 1. Here it was radius equals 4 adjacent. No, it was the opposite equals negative root 7. And that's x, and that's r. Okay, so let's actually find the opposite this time. So we know 4 squared equals negative 1 squared plus y squared, which means y squared equals 4 squared take negative 1 squared. So y equals 4 squared take 1. Root 15, or it could also be negative root 15 because this one's positive root 15 and down this way it's negative root 15. So we're going to have to do it for both, which is going to give us our two answers in two different quadrants. So let's have a look at question 1. We know cos theta, let's find sine theta. It's opposite over adjacent, so we've got positive root 15, not opposite over hypotenuse, so it's positive root 15 over 4, or we could have had negative root 15 over 4. Number 2, tan theta, opposite over adjacent. So this time we've got opposite root 15 over adjacent, -1, or negative root 15 over -1. So this would come out as just negative root 15 or positive root 15. That's question 4.